Alright, so this is your Chapter 6 exam review. So let's go over number 1. It says, find the values of the variables in the parallelogram. The diagram is not to scale. Alright, so since we know that this angle is 102 degrees, well, let me go back even further than that. Since we know this is a parallelogram, we know this angle here and this angle over here are supplementary. So that means they add up to 180. So if we know they're supplementary, 180 minus 102 is what? Well, it comes out to 78 degrees. Okay, so we know that this entire angle is 78 degrees. Okay, so we know if this is 29, we know that the other angle has to be 49. So we know this has to be 49 degrees. All right. Now, if you notice, these are two parallel lines, and this 49 degrees and this y here, they are alternate interior angles. So we know that y here has to be 49 degrees. You can confirm that by adding all three of these together. 29 plus 49 plus 102, and it does come out to 180 degrees. Now, we also know that opposite angles are congruent as well. So we know that this is 102 degrees. And we also know that 29 and x are another pair of alternate interior angles. So we know that this has to be 29 as well. So x is 29, y is 49, z is 102. The answer is D. All right. So there's number 1. Let's go on to number 2. I gotta turn my smart ink off. Oh, it doesn't work. Let me just do this. I thought. Okay. Come on. Here we go. All right. So number 2. It says in this parallelogram, the measure of angle KLO is 69 degrees. So we know that's 69 degrees. Oh, 69, not 60. MLO is 47 degrees. All right. Find KJM. So we want to find this entire angle here. Well, we know that this entire angle is equal to this entire angle. So all we have to do is add these two together. So 47 plus 69 is 116. So we know that the measure of this angle equals 116 degrees. So the answer is C. All right. Let's go on to number 3. All right. In the parallelogram, the measure of QRP, so this angle here is 46 degrees, and PRS is 50 degrees. Find the measure of PQR. All right. Well, we know that this whole angle here and this entire angle here equal 180. So all we have to do is add these together, subtract that from 180, and we'll get our answer. So both of these together, 50 plus 46, both of these together this is a 96 degree angle. All right, so 180 minus 96. This angle up here is 84 degrees. All right, 84 degrees. Because remember, both of these angles here are supplementary. Because in a parallelogram, consecutive angles like this are supplementary. All right, let's keep going. Number 4. In this parallelogram, measure of angle 2 is 5x minus 28. Measure of angle 4 is 3x minus 10. What's the measure of angle 3? Well, we know that 2 and 4 are congruent to each other. So we can set these equal and solve for x, and that'll give us the measure of 4, and then we can easily find the measure of 3 from there. So 5x minus 28 equals 3x minus 10. So add the 28, add 28, minus 3x, minus 3x. So 2x equals negative 10 plus 28 is 18. Divide both sides by 2, so x is 9. So plug it in. 3 times 9 minus 10. 3 times 9 is 27. Minus 10 is 17. So the measure of angle 4, is 17. All right, so this one equals 17. So now all we have to do is do 180 minus 17, and we have our angle. Well, 180 minus 17 is 163. So our angle is 163 degrees, letter D. All right. Number 5. It says supply the missing reason for the proof. All right. So given parallelogram with diagonal BD, prove that triangle ABD and triangle CDB, so these two triangles, we need to prove them congruent. All right. So AD is parallel to BC, that's definition of parallelogram. Angle ADB is congruent to angle CBD. Well, yeah, that's true because those are alternate interior angles. Side AB is parallel to side CD. Well, if you notice, that's similar to number 1. All right. And in number 1, it was definition of parallelogram. So in number 3, it's going to be the same answer. Definition of parallelogram. So the answer here is letter B. Definition of parallelogram. Okay. Number 6. In this parallelogram, DH is x plus 3. GH is 4x minus 5. What am I at? HE is 2y plus 3. And HF, I skipped, is 3y. So since it's a parallelogram, we know the diagonals bisect each other. So we know x plus 3 equals 3y because we know this section is congruent to this part and this part is congruent to this part. So now we also know that 4x minus 5 equals 2y plus 3. Now what we need to do here, since we have two variables in each one, we need to try to solve one of these for a single variable. Now there's multiple ways to do it, but one way you can do it is, here since we have x plus 3 equals 3y, we can just subtract 3 from both sides and get x equals 3y minus 3. Now that we know what x equals, we can take this number, the 3y minus 3, plug it in for this x, and then we only have y's in our equation. So 4 times 3y minus 3 minus 5 equals 2y plus 3. Do the distributive property. 12y minus 12 minus 5 equals 2y plus 3. So 12y minus 17 is 2y plus 3. So subtract 2y minus 2y, add the 17, add the 17. So 12y minus 2y is 10y equals 3 plus 17 is 20. Divide both sides by 10. So y equals 2. So that rules out this one, and this one. So that means our answer has to be C. To double check your answer, what you can do is take that y, plug it back into the equation of x plus 3 equals 3y. Okay, remember that was our original equation up here. Okay, so plug it back into there. So we have x plus 3 equals 3 times 2. So x plus 3 equals 6. Subtracted 3 from both sides to get x equals 3. All right, so that just confirms that our answer is letter C, x is 3, and y is 2. All right, moving right along. Number 7. All right, so in this diagram here, it says if in the figure, the horizontal lines are parallel. So all 4 of these lines are parallel. And then it says AB is congruent to BC, which is congruent to CD. Now, since these lines are parallel and this transversal is cut into equal segments, any transversal that goes through these parallel lines is also cut into equal segments. So since ML is 8, LK is 8, and kj is 8. All right. Now it wants the measure of jm. Well, jm is the distance from here all the way to here. So it's 8 plus 8 plus 8. And 8 times 3 is, of course, 24. So 7 is letter D. All right. Because remember, any transversal that goes through these lines now will be cut into congruent segments because this one is cut into congruent segments. Number 8. In the figure below, the lines are parallel, so these four here, these four horizontal lines are parallel. This is cut into equal segments. So we automatically know that this is 7.6, this is 7.6, this is 5.1, and this is 5.1. So find KL. Well, KL is 7.6, and find FG. Well, FG is 5.1. So KL 7.6, FG 5.1, 8 is letter D. All right, because remember, since these lines are parallel and one transversal is cut into equal segments, any transversal that goes through there are also cut into equal segments. All right. Number 9. All right, for which values x and y must this be a parallelogram? Well, again, we know that in a parallelogram, the diagonals bisect each other. So we know that these two segments are congruent and these two segments are congruent. So 4x minus 2 equals x plus 28. We also know that 4y minus 7 equals y plus 14. So now what we're going to do is solve this out. So plus 2 minus x minus x. So 3x equals 30. Divide both sides by 3. X equals 10. That's a 0. So that rules out this one. And that's it for now. So now let's solve these. Add 7. Add 7. Subtract y. Subtract y. So 3y equals 14 plus 7 is 21. Divide both sides by 3, and y equals 7. So our answer for number 9 is C. X is 10, y is 7. All right. Moving right along. Number 10, which description does not guarantee that the quadrilateral is a square? Okay, so the square is both a rectangle and a rhombus. Yep, if it's a rectangle, if it fits into the rectangle category and the rhombus category, means it's a square. Is a parallelogram with perpendicular diagonals. Now, perpendicular diagonals, a rhombus has perpendicular diagonals, and since a square is a rhombus, that means by default it also has perpendicular diagonals. Okay, but just because a parallelogram or a quadrilateral has perpendicular diagonals does not necessarily mean it has to be a square. All it means is it has to be a rhombus. So letter B is a possible answer. Let's look at C. Has sides congruent? Has all sides congruent and all angles congruent? Well, if it's quadrilateral with all angles congruent, that means they all have to be 90 degrees. And if all the sides are congruent, that means it has to be a square. So that's not the answer. And then the last one has all right angles and has all sides congruent. Well, that's basically C stated over again. All right. So the answer for number 10 is letter B. Okay. Because remember, a rhombus has perpendicular diagonals. Yes, a square does have perpendicular diagonals, but only because it's part of the rhombus family. Okay, so just because it has perpendicular diagonals does not guarantee it's going to be a square. All right. Now, number 11, what is the most precise name for quadrilateral ABC with these vertices? So what you're going to have to do, we're going to have to graph this. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2. So negative 2, 2, 0, 4, 6, 4, and 4, 2. All right, now, so here, that's terrible connecting the dots. All right, so here's our parallelogram, or quadrilateral, sorry. Now, there's a couple things we can do here. We can look through it and kind of reason through this and get our answer, or we can use our slope formula and our distance formula and things like that to get our answers, okay? Let's try to reason through it first and see if we can get our answers. Well, both of these points here have a height of 2. So that means this is a horizontal line. Both of these as well have a height of 4. Because remember, this is A, B, C, and D. So they both have so B and C both have a height of 4. So that means that these two are horizontal lines and they are parallel. Now, to get from A to B, we went up 2 and over 2. So this has a slope of, so AB has a slope of 1. Now, to get from D to C, we also went up 2 and over 2. So it also has a slope of 1. So we also know that these two lines are parallel. Okay? So now we know that opposite sides are parallel. So that narrows it down to quadrilateral. That narrows it down to a parallelogram. And since A and D are also parallelograms, that rules out C as an answer. Now, a rhombus has all sides congruent. Well, just by looking at this, even though it's not technically drawn to scale, it's still drawn on a coordinate plane. So it should be pretty much to scale. And as you can see, the distance between BC looks a lot more than the distance between A and B. Okay, so that rules out rhombus. And since we know that since we know that AB has a slope of 1 and BC has a slope of 0, they're not opposite reciprocals. So that rules out rectangle. And like I said, these two lines clearly do not look the same length. So that makes it a parallelogram. Now, to prove that these two aren't, you'd have to run all this through the distance formula. So the length of AB, let's make B2 and A1. So we're going to do x2 minus x1, so 0 minus negative 2, which is 2 squared, plus 4 minus 2, which is 2 squared. So this is going to be 4 plus 4, which is 8. So this has a side length of square root of 8. And then we can do BC. All right, let's make this point 2 and this point 1. So x2 minus x1 is just 6 squared, plus 4 minus 4 is 0 squared. So this is just the square root, because this is gone. So this is the square root of 6 squared. The square root cancels out the squared, leaving it just 6. So this has a side length of 6. Okay, so adjacent sides are not the same length. So again, that rules out rhombus. We ruled out quadrilateral because opposite sides are parallel. We ruled out rectangle because AB has a slope of 1, BC has a slope of 0. So it has to be just a parallelogram. All right, has to be just a parallelogram. All right, number 12. Which statement is true? All quadrilaterals are rectangles. Nope, just proved that in number 11. All quadrilaterals are squares. Nope, because a square is a rectangle. So if all quadrilaterals aren't rectangles, they can't all be squares. All rectangles are quadrilaterals. Well, yeah, because a quadrilateral is just a four-sided figure. So that's true. And then all quadrilaterals are parallelograms. Nope, because you can have trapezoids and kites as well. So the answer for number 12 is C. All rectangles are quadrilaterals. That is the only one that makes sense. All right. Number 13. In this rhombus, measure of angle 1 is 106. So 106. What are the measures of 2 and 3? Well, remember in a rhombus, opposite angles are congruent. Well, that's any parallelogram. So we know this is 106. Now, since we know this is an isosceles triangle, we know that this angle here and angle 3 are congruent. So that means you just take 106, subtract it from 180, 180 minus 106, and then whatever answer you get there, just simply divide it by 2. All right, so 180 minus 106 divided by 2. So that means that 3 is 37 degrees, and so is this angle, but we really didn't need it. Whoops. I don't know why I wrote 307. Anyway, just ignore that. All right, so we know that 2 is 106 and 3 is 37, so that looks like, totally missed it. That looks like the answer is C. All right, the answer is C. Because again, 1 and 2 are congruent, and then since this makes an isosceles triangle, all you have to do is subtract 106 from 180, divide it by 2, and that gives you each of those. All right. Number 14. Find the measure of the numbered angles in the rhombus. Well, what do we know about the diagonals of a rhombus? Hopefully you just said they're perpendicular. So that means the measure of angle 1 is 90. All right. Remember, opposite angles are congruent. And also, the diagonals of a rhombus are bisectors. So that means 2 is 41 degrees also. All right, so we know this is 90 and this is 41. So add those together and subtract it from 180. 90 plus 41 is 131. 180 minus 131 is 49 degrees. So angle 3 here is 49 degrees. So 1 is 90, 2 is 41, 3 is 49. So it looks like the answer is letter D for number 14, letter D. Okay, moving right along. If I go too fast, just simply rewind me. All right, parallelogram ABCD has angles measured shown below. Can you conclude that this is a rhombus, a rectangle, or a square? Explain. Well, if we notice here, these two, if we just look at this top triangle here, ignore the bottom one for a second. If we just look at this top triangle, since these two angles are the same, we know this is an isosceles triangle. So we know that those two angles are the same. And we also know that the sum of these minus 180 equals this angle right here. Well, 58 plus 58 is 116. And if we subtract that from 180, we get 64 degrees. So we know this top vertex here is 64 degrees. All right. Now let's look at this bottom triangle. Well, it looks the same way. We have two 58-degree angles here. So we know this is also an isosceles triangle. Okay. And now, since this is 64 degrees, we know this is 64 degrees as well. All right. Now, the real question is do we know if this is a parallelogram, a rhombus or not? Okay. And the quick answer is yes, we do. All right. I didn't actually have to do all this work. I just wanted to do it because I wanted you to remember your properties of isosceles triangles as well as rhombuses. All right. But if you notice, this diagonal here bisects this angle. And since we know it's a parallelogram, not a kite, the diagonals are only bisectors when you have a rhombus. Okay. Remember, one of the diagonals in a kite bisects the angles, but since we already knew it was a parallelogram, we could rule out kite. And since this diagonal is an angle bisector, it is a rhombus. Okay, so I kind of did it the long way, but the short way is it's a rhombus because it bisects the angles. Okay, and we know it's not a square because the two 58s don't add up to 90. And we know it's not a rectangle for the same reason. It doesn't add up to 90, and there is enough information, so that one's wrong too. All right, 16. Lucinda wants to build a square sandbox, but she has no way of measuring angles. Explain how she can make sure that the sandbox is a square by only measuring length. Well, what do we know about a square? Okay, we know that a square has 4 equal sides. Okay, we also know in a square that the diagonals are the same length. Okay, so if we measured all 4 sides and saw they were the same length, and then we measured the diagonals and saw that they were the same length as well, we would have a square. Because if we just knew the sides were the same length, all we could say is a rhombus. And if we just knew the diagonal was the same length, we could only say a square. But if we have both, sorry, a rectangle. But if we have both, then we know it is a square. Okay. So arrange four. So let's go through the answers. Arrange four equal length sides so that the diagonals bisect each other. Nah, because in every parallelogram the diagonals bisect. Arrange four equal lengths so that the diagonals are equal lengths also. That is exactly what we just talked about. So 16 is B. Because remember, four equal lengths says rhombus, equal length diagonals says rectangle. You combine them both, you get a square. Okay. 17. Find the values for A and B. All right, well, since we have a trapezoid here, because these two are marked congruent, these two are marked parallel, and these are not marked parallel, so we know it's a trapezoid. Well, we know adjacent angles or consecutive angles in a trapezoid are supplementary. So 113 plus B equals 180. So just 180 minus 113. So B is 67 degrees. And do the same thing over here. Just do 180 minus 36. A is 144 degrees. 144, 67. Boom. 17 is A. All right. Let's keep going. 18. This isosceles trapezoid is part of an isosceles triangle with a vertex angle of 46 degrees. What is the measure of an acute base angle of the trapezoid? So, an acute base angle of the trapezoid, that would be these two. Okay, since we know it's an isosceles trapezoid, we know they're the same, so all we have to do is find one of them. Well, we have an isosceles triangle here as well, and we know that these two are the same in the isosceles triangle. So all we have to do is take 46, subtract it from 180, and divide it by 2. So 180 minus 46 is 134. Divide that by 2. We know both of these are 67 degrees. All right. And we also know now, so that's the first part, 67. So we can rule out these two. Okay. Now it says an obtuse base angle. Well, the obtuse base angles are these two up here. Since it's a isosceles trapezoid, we also know they're congruent as well, so we only have to find one of them. Well, in a trapezoid, these two angles here are supplementary. So all we have to do is 180 minus 67, and that gives us 113 degrees for both of these angles. So it looks like our answer for 18 is B. All right. Moving right along. Number 19. LM is a mid-segment of the trapezoid. AB is 46. BC is 125. We want to find a measure of LM. Well, if you remember, LM equals half the sum of the bases. So take 125, add 46. 125 plus 46 is 171. Divide that by 2, and you get 85.5. So 19 LM is 85.5. 19 is letter B. All right, because remember the mid segment, okay, LM equals 1/2 of AB plus DC. Okay, and 20 uses that same formula. Okay, 20 uses that same formula, but now instead of numbers, they gave us expressions. Still works the same way though. This is x plus 8. This is 4x plus 3. And they did actually give us a number for this one. It's 201. Well, we know this plus this equals half of this. Or 2 times this, 2 times LM equals AB plus DC. So if you don't want to do a fraction, we can do 2 times 4x plus 3 equals x plus 8 plus 201. All right, that's the same formula because this equals half of this, or 2 times this equals this. So that's what we're going to use. Distribute the 2. 8x plus 6 equals x plus 209 minus 6 minus 6 minus x minus x. 7x equals 203. Divide both sides by 7. 203 divided by 7, it is 29. All right, so we just want the value of x, and the value of x is 29. We found it. Remember your formula for this. Lm equals 1/2 of AB plus DC, or you can use the one we did, which is 2 times Lm equals AB plus DC. All right, you can use either one. It doesn't matter. They will both give you the same answer, except this one has a fraction and this one doesn't. Okay, it's the only difference between the two. Let's go to 21. Find the measure of angle 1 and the measure of angle 3 in the kite. Well, we know that the diagonals of a kite are perpendicular, so boom, we know that's 90. We know that AC is an angle bisector because it connects the vertices between the congruent sides. All right, so we know that 1 is 39 degrees. So we can rule out this one and we can rule out this one, because you want to put them in order, the measure of 1, then the measure of 3. Now, so now all we have to do is find the measure of angle 3. Well, if we know the angle up there at A is 39, and we know this is 90, just add those together. 90 plus 39, that's 129. Now just subtract that 129 from 180 to get 3, which 3 is 51. Because basically all I did was just made this into a triangle with a 90-degree angle and a 39-degree angle. Add them together, subtract from 180, this is 51. Okay, that's all I did there. Moving right along. 22. The measure of angle R is 130 degrees. Measure of angle S is 80. Find the measure of angle T. Well, in a kite, the angles between the congruent sides, so in this case, I'm sorry, but between the non-congruent sides. So in this case, Q and S, okay, excuse me, they are supplementary. So both of these are 80, and we have R's 130. Now we know all four of these has to add up to 360. So all you do is add those three up. That equals 290. Subtract that 290 from 360 to get T is 70 degrees. So B is 70. All right. Moving along. 23. Find the values of the variables and the lengths of the sides. All right. So we know these two are congruent and these two are congruent. All right. So y minus 4 equals x plus 5. And 2x plus 5 equals x plus 12. Now I'm going to solve this one first because we have the same variable in both. Minus 5 minus 5 minus x minus x. X equals 7. So that rules out B and D because x is 16 in both of them. Now I'm going to plug the 7 in for this x right here. So y minus 4 equals 7 plus 5, which is 12, plus 4, plus 4. So y equals 16. Okay, well, x is 7, y is 16, so we can't rule one out just yet. But now that we know what y and x are, we can just plug them in. Well, we already found the length of this side by finding y. X plus 5 is 12, so we know this is length 12. Okay? Now we can come down here and do the same thing, plug in a 7. 7 plus 12 is 19. So the answer here for number 23 is C. X is 7, y is 16. The shorter side is 12. The longer side is 19. All right? Moving right along. 24. I did this one in class. Which diagram shows the most useful positioning and accurate labeling of a kite in the coordinate plane. So if we look at this one, here we have negative a0 and b0. That's okay. Here we have 0c, here we have 0, negative d. That's not okay because we don't know which one of these diagonals is the actual bisector. Because remember, one of the diagonals bisects the other one. Well, we can't really tell that from this diagram. So A's out. Let's look at this one. Yeah, this one's not really that helpful either. Let's look at this one. No, this one's not that great either. Let's look at this one. Negative a0, b0, it's kind of looking like A, but if you notice, this says 0c, this says 0, negative c. So we know that these are the same exact length. So we know this is the diagonal that bisects each other. So we know that this diagonal here bisects these angles. All right. So letter D is the most useful positioned and has the most accurate labeling. Okay. That's what differentiates D from A, is it has the most accurate labeling. Right? Because we can clearly see that this is distance C and this is distance C. Over here, we can't determine that. We know this is distance D and this is distance C. And then this is distance B and this is distance A. So that really doesn't help us at all. All right, so that's why it is letter D, because it has the most accurate, the most useful position, and the most accurate labeling. Okay. 25. In the coordinate plane, three vertices of rectangle HI, JK are those three. What are the coordinates of point J? All right, so let's draw it in here. We know it's a rectangle. H is 0, 0. I is 0D. K is E0. So this is 0, 0. This is over E up 0. This is up D over 0. So we want to know what this point is right here. Well, to get to it, since we know it's a rectangle, we know this is a 90-degree angle. So we went over E and up D. So ED would be the correct answer. 25 is C. All right. Number 26. The vertices of a trapezoid are the origin along with A is 4A, 4B, B is 4B, 4C, and C is 4D, 0. Find the midpoint of the mid-segment. So we know this is 4A, comma, 4B. This is 4C, comma, 4B. And this down here is 4D, comma, 0. So what we have to do is we have to find both of these midpoints first. Okay. Remember, your midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 divided by 2. So 4a plus 0 is just 4a, divided by 2 is 2a. And doing the same thing for this one, you're going to get 2b. Because 4b plus 0 is 4b, divided by 2 is 2b. Now let's look at this one. X's are going to be 4c plus 4d divided by 2, which is going to give us 2c plus 2d. That's a b. Okay, 2c plus 2d, comma, 4b minus 0 or plus 0 is just 4b divided by 2 is 2b. Okay, all I did here for the x's was 4c plus 4d divided by 2. Well, you can pull a 2 out of here and cancel it with the 1 on the bottom, so both of these 4's become 2's and the fraction disappears. And then of course 4b minus 0 is just 4b over 2. Well, the 2 cancels with the 4 and makes it a 2. Okay, that's all I did for that. Now we have to use those points and find the midpoint of the mid-segment. So x2, let's just say 2a, plus 2c plus 2d, divided by 2, comma, 2b plus 2b, which is 4b, divided by 2. This one's easy. This goes back down to 2b. And then this, you can factor out all these 2's, and then it'll cancel with the 2 in the denominator. So this will be A plus C plus D. All right, so C is your answer. All right, moving right along. 27 says, for the parallelogram, find coordinates P, okay, without using any new variables. All right, so we know this is C, okay, so we can call this point C0, all right, and then we know the height of this point is going to be the same height as this point, so we know it's going to be B, all right. Now, we know the distance from here to here is A because that's the x-coordinate of this point. So we had to go over A before we went up to this point. So we know this is distance A. We know the distance from here to here is C. So that means since this is a parallelogram, we know the distance from here to here is also C. So that means the distance from the y-axis out to P is going to be A plus C. And of course, it has a height of B. So the answer is C. A plus C, comma, B. All right? Just remember, opposite sides are congruent. So if this is C, this is C. The distance from here was A because we had to go over A before we came up to this point. This plus this is A plus C, and that's how far it is to here. All right? 28. What type of quadrilateral has all sides congruent? You might want to jump to a square, but we don't know anything about the angles. So we have to say a rhombus, okay? Because if you're not given the angles or the slopes of the lines, all you know is all four sides are the same length. The most accurate definition you can give is a rhombus, all right? 29, and we're almost done here, guys. In a coordinate plane, draw a square with sides 4q units long. Give the coordinates of each vertex and the coordinates of the intersection of the diagonals. All right, I'm actually going to draw this two ways. You could draw it this way. All right, it's a square with sides 4q long, so we know this is 4q and this is 4q. So we know this is your vertex 0, 0. We know this is 4q, comma 0. We know this is 4q, comma 4q. And we know this is 0, comma 4q. Now, the intersection of the diagonals right here. Well, we know the intersection is the midpoint of one of them, so all you have to do is run both of these. Just run this through the midpoint formula, and you will get that they cross at 2q, comma 2q. All right, so that's the intersection of the diagonals. All I did was run it through the midpoint formula to find the midpoint of this diagonal. Okay. Now, there's also another way you can do this. Here, I put a vertex at the origin. But what you can also do, okay, I'll leave that up there. What you can also do is center the square around the origin. So you can also draw it like this. Either way is going to be right. All right, this has a length of 4q, which means, and since it's centered at the origin, we know all of these are the same length. Okay. So that means this vertex here, we're going to go over 2q and up 2q. So this will be 2q, 2q. All right, we know this is going to be negative 2q, comma, positive 2q. We know both of these down here are going to be negative. Oops, forgot my negative. But we know this one is going to be positive 2q, comma, negative 2q. Now, when we draw in our diagonals, the diagonals are going to cross at the origin, 0, 0. All right. And again, all you have to do is run it through the midpoint formula. Just run one of these through it. If you look, it's negative 2q plus 2q, which is 0. 2q minus 2q, which is 0. 0 divided by anything but 0 is 0. All right? So 0, 0. All right? So this is two legitimate ways that you could do this problem. Neither of them's wrong. Neither of them is more right than the other one. They are both correct answers. Okay? And the final one, this video is rolling up on 45 minutes long, so let's do this last one. Is this quadrilateral a parallelogram? Well, if we look, opposite angles here are congruent. This is 41 degrees. 180 minus 31 is 41 degrees. So yes, it is, because opposite angles are parallel. Opposite angles are congruent, making opposite sides parallel. Okay? So yes, opposite sides. I'm not sure if this is the same wording they give, but it means the same thing. Yes, opposite angles are congruent, making opposite sides parallel. All right, and we're done. So your test is tomorrow in class, so make sure you come ready to take the test. All right, watch this video as many times as you need to. If you need to, you can always email me, and I can try to answer your question over email as well. All right, so good luck, study, 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 and see you tomorrow.